All attendees are in listen-only mode.
Okay, good afternoon, everyone. I want to welcome you to today's sustainability seminar, to our audience here as well as those we have listening online. This seminar, as with all of our other talks, will be archived on the ISTC website in a couple of days. We've got the last 5 years of talks, about 75 talks on the website if you want to look at any of those other topics on sustainability that we've covered. For today's talks, I'd like us to hold the questions till the end of the presentation, and for those online, they can type their questions in and we'll answer those at the end also. For today, we're very pleased to have with us 2 representatives of Rock Island Clean Line, which is a project that will bring wind energy power to the eastern U.S. Our speaker is Hans Detweiler, who's Director of Development for the Rock Island Clean Line. Hans is responsible for managing the siting process, permitting efforts, public outreach, environmental considerations, as well as the strategic planning necessary for the development of this line. Hans works to integrate and align Rock Island Clean Line's regulatory process with outreach activities in the states that will benefit from the transmission project. Prior to joining Clean Line, Hans was Director of State Policy for the American Wind Energy Association, supervising all of their direct state legislative campaigns and state regulatory efforts, and serving as the primary liaison to their regional partners. Previously, Hans was the Deputy Director of the Illinois Department of Commerce and Economic Opportunity. Hans has also worked in a variety of policy and advocacy roles with organized labor and other nonprofits. He holds his BA degree in political science from Grinnell College in Grinnell, Iowa. Rob Martin is also here from the company today. Rob serves as the Illinois Outreach Coordinator and has been with Clean Line since September 2012. He's currently completing his master's degree in project management at ISU, and he holds a bachelor's degree from there in engineering technology and renewable energy. Rob has set out some materials about the Clean Line Energy Project on the side table for those of you here who would like to collect those after the talk. So with that, I'd like to turn over the program to Hans Detweiler. Thank you for coming.
It is a great pleasure to be here today. I was thinking about this last night, and so I took a job in 1998 working for the Environmental Law and Policy Center, which is a little further back than the resume went there. But the purpose of that job was to begin to organize a statewide network of people who wanted to do things about climate change and, have the state take appropriate actions legislatively to support renewable energy development and energy efficiency development. And so I was driving all over the state building local groups of supporters in that, and I got to come to the university here a bunch of times back in the day doing that, and I always had a good time coming here. And unfortunately, as I got to think about it more, I realized, wait a second, so that was 1998. And since then, I think all 10 of the world's warmest years have occurred since that time. So unfortunately, we still have a lot of work left to do on the climate issue. But I do think that there are a lot of very exciting projects, both technologies that are under development here in this building and this program that can help put our planet on a more sustainable path. And the project that I'm here to talk about today would make a significant contribution to a more sustainable energy mix. I'll explain the details later, but our best estimate is that it would reduce, just this project would reduce the electric sector CO2 emissions in the state of Illinois by approximately 9%. So a pretty good reduction that would result from all of the new wind that a project like this could facilitate. So to introduce our company a little bit, the company is Clean Line Energy Partners, and what Clean Line does is develop long-distance, high-voltage, direct current transmission lines that go from the really windy areas of the country and serve consumers who need the power. And the reasons that you need a company to do this, I'm going to show you in a couple of maps. One of the fun things about being a, did I just do that? one of the fun things about being a transmission developer is you get to play with maps like all the time. So, so that's good. Anyway, what this map shows is this is onshore wind resources, and the purple areas are the best wind resources in the country. The green area is not so good. You do see north central Illinois definitely has some very, very good developable wind resources, and I expect that those resources will continue to develop for a considerable amount of time. However, what you do see is that the best areas, those purple areas, are right in that band in the middle of the country. Am I driving this, or okay? There should be one more. All right, we'll get it worked out. Oh, I can drive. Okay, all right, great, thanks. So this map shows the existing transmission line system in the country. Basically, the higher the voltage the line, the bolder the line is on this map. And what you see here is that, unfortunately, it's the inverse of the wind resource map. So whereas the wind resource map, all those purple areas are right smack in the middle of the country, that's exactly where the grid is the weakest. And so if you want to connect those two, then you need a new transmission system that can support that, facilitate that as efficiently as possible. And that's what our company is working on. So we've got 4 projects which are all very similar. They're all high voltage, direct current, long distance, interstate, interregional projects to facilitate large amounts of wind energy development in the middle of the country and serve that to consumers. The project I'm going to talk about the most today is the Rock Island project. It's furthest along here in Illinois, although the Grain Belt project, which starts in Kansas and would deliver into Sullivan, which is sort of near Terre Haute, Indiana. It's right on the Illinois-Indiana border in there. That project is coming right along as well, and also certainly traverses Illinois, and geographically is a little closer to where we are here today in Champaign. So to say a little bit about the project specifically and the scale of the project, it's 3,500 megawatts of wind that would be facilitated. That is a pretty large amount of wind, and I'll explain that in a bit. But all of it would be picked up in the wind resource area, which is that 4-state area, Iowa, Minnesota, South Dakota, and Nebraska, and would be delivered and able to serve the renewable energy standards in all of those more easterly states there. So we've already applied for and received our approval from the Federal Energy Regulatory Commission, and we need approvals from the 2 state agencies, the Illinois Commerce Commission and the Iowa Utilities Board, to approve the project as well. So how much power are we talking about? 3,500 megawatts. That's approximately 15 million megawatt hours a year, which is roughly 3 times the annual energy supplied by the Hoover Dam. So you are talking about a very significant amount of power. Another way to say it would be it's the equivalent annual energy consumption in Illinois of about 1.4 million homes, electric energy consumption, about 1.4 million homes. It's more power than the entire state of South Dakota consumes in a year. So it's a lot of power. So I've mentioned a couple of times that we are developing the project as a direct current project, and the reasons that we've selected direct current as technology, it's not really that direct current is new. Direct current is actually as old as the light bulb. It's been around for a long time, but it makes sense in certain applications, and in particular in long distance applications. The cost efficiency, the cost efficiency is superior when you're going a long way because the load losses are a lot less. So specifically in Iowa, most of the backbone electric grid in Iowa is 345 kV AC. If you were to go 500 miles at 345 kV AC, your total losses on the system would be approximately 15%. With our project with direct current 600 kV DC, the losses would be approximately 5%. So roughly a third of the losses. And if you think about that in terms of a 3,500 megawatt capacity project, that's the equivalent of an entire 350 megawatt wind farm vaporizing, which is roughly the scale of that huge wind farm that's in Bloomington Normal in east of Bloomington Normal in McLean County. So you think about that much energy just vaporizing from load losses. It's highly cost effective to use a technology that is more efficient. The reason that DC is not used more frequently is that it is high cost to build the converter stations to go back and forth from AC to DC. And when I say high cost, I literally mean each of the converter stations at each end are $250 to $300 million. So the total project cost is about $2 billion, and of that, $600 million or $300 million at each end is the 2 converter stations. So if you want to build a wind farm in Champaign-Urbana and you want to deliver it to Chicago or St. Louis, AC is the right way to go from a cost-effectiveness perspective. It's not going to be cost-effective to build the converter stations. But if you're going more than 400 miles, if you're going 500 or 700 miles like some of our projects do, it makes a lot of sense. The other great advantage of DC is the footprint is a lot less, again, because DC, because of the higher efficiency and the way that direct current actually utilizes the whole structure of the entirety of the conductor material, whereas with AC, with a transmission line, it has a skin effect, and the electricity is really only traveling on the outer surface of the conductors. So because it's more efficient, the land use impacts are a lot less. And so, if you want to see a lot of wind farm development and you want the transmission that is required to support that, but you don't want to wake up and have transmission lines running pell-mell all over the place, then direct current really can help reduce the amount of land use footprint that is required for the transmission. I mentioned the converter station. There's actually an operating DC system in the upper Midwest that runs from central North Dakota to Minnesota, near Minneapolis. That project is roughly 30 years old and existed to serve lignite coal in North Dakota. Same thing, it's sort of a long-distance project, but this is a picture of the converter station. The way that it would work is we would have wind farms would be built in our resource area in northwest Iowa, and then they would come in via radial lines, just direct connector lines to our converter station. And then it would switch to direct current, and then it would go direct current all 500 miles, so it gets to Illinois, to a point near Morris, Illinois, and then it would switch back to AC, and it would plug into the existing 765 kV system here. And then from there, it can serve any consumer. It can serve customers in Illinois, or it can continue. It's on the national backbone grid. It can go further east from there as well. In terms of total economic benefits of the project, there are about 500 permanent jobs that would be associated from this. Most of that is in the construction of the wind farms that would occur to the west. There are 5,000 construction jobs, about 500 permanent jobs. So most of those permanent jobs would occur mostly in the western region. The construction jobs would occur across the project area, and there would be significant construction jobs here in Illinois. The total wind farm investment is about $7 billion. Interestingly enough, Illinois is one of the leading states in the production of wind turbine components. So over in Clinton, Illinois, you've got Trinity Structural Towers. They make the towers for wind turbines. You've got a couple of gear manufacturers. Broadwind has a facility at Bradfoot Gear Works in Cicero, a couple hundred people making gears for wind turbines there, and then Elgin Winergy, which is a Siemens affiliate, has another several hundred people making wind turbine components. So there are a lot of economic benefits as you go through the supply chain in Illinois of a project like this. We've also announced that we would buy all of the conductor for the project from Southwire, which is a company that has their production facility in Flora, Illinois. So that's roughly a $70 million purchase, and it'll keep that factory going for about a year. So pretty significant economic benefits to the supply chain in Illinois as well. I think when the project is being considered by regulators and others in the electric power industry, one of the things that they're really going to look at is what are the consumer benefits of the project for Illinois. And basically, according to the law of supply and demand, if you're injecting 3 times the annual Hoover Dam into Illinois markets, then you're going to have a significant impact decreasing power prices. And we've seen that from other wind farms that have been built in the state previously. and we expect to see that again. We did a study. We hired some economists to do the study, and their findings was that just in the first year, total wholesale electric prices in Illinois would drop by about $320 million. So very significant consumer benefits that would come from a project like this. Additionally, I already mentioned the some of the environmental benefits, significant CO2 benefits, but also sulfur dioxide and the nitrogen oxides that cause acid rain and types of precursors to smog. Those reductions are also significant. And people don't think about water reductions as well, but when you have existing thermal power plants, they are one of the major consumers of fresh water and need to have a lot of water for their cooling loads. So you also get very significant water savings from switching to wind as well. What I want to show here is the total demand for renewable energy. And the reason this comes up is sometimes people ask the question, okay, look, I know that we want more renewable energy, but do we really have enough demand for 3 times the Hoover Dam? Is there really a market for that much renewable power in the near future? What this chart shows is the blue line is total demand from all of the states that are in PJM for renewable energy. Now, PJM, you're forgiven if you don't know what that is. It used to stand for Pennsylvania, Jersey, and Maryland. Today, it simply is the regional transmission organization that runs the grid for the area that starts with ComEd in Chicago and goes basically all the way to the Atlantic states, to Pennsylvania, Jersey, Maryland, Delaware. And so it's a huge market. It's the largest single electric market in the United States. And many of those states, Pennsylvania, Jersey, and Ohio, have renewable energy requirements. And those requirements increase over years. Illinois' requirement is 25% by 2025, which is a pretty significant requirement. And what you see, the other things you see on this chart are the orange is all of the existing wind that has been built within PJM. The gray is what was under construction when we did this slide around the end of last year. And then the green is the amount of power that would be represented by the Rock Island project when it's built. So what you can see is that Illinois wind farms can, in Indiana wind farms, you can double and triple the total amount of energy that would be supplied by those wind farms. You can continue to build a lot more Illinois wind farms, but you're still going to need power from a Rock Island project. So we think the demand is definitely there. Now, this is a good one to talk about on a university campus. This is actually one of my favorite slides, and it lets me wonk out just a little bit. What a lot of people recognize as the biggest problem with wind energy is that wind energy doesn't always blow. And what do you do? What do you rely on when the wind isn't there? What this table is communicating is the correlation of wind in different resource areas. And so a 1.0 correlation is a perfect correlation. So if your Iowa wind and your Illinois wind, if one is on, then the other is always on. That's a 1.0 correlation. A 0.0 correlation simply means one cannot predict the other. And a negative correlation would mean if one is on, then the other is always off, right? And what you would want to have is a low or a low negative correlation so that you would have a nice flat production curve. And what this shows is that, for instance, if you look at Illinois and Indiana, the correlation between those two wind regimes is 0.75. So if you try and rely exclusively on Illinois and Indiana wind resources to meet Illinois' load, they're going to look a lot alike, and you're going to have problems with the variability that will be very significant. However, if you're blending in resources from across the country over a broader geographic area, then you get much lower correlations. And so, for instance, relevant to the Rock Island project, the Iowa to Illinois correlation is the 0.19. I mentioned our Grain Belt project earlier, Kansas. So it starts in Kansas and delivers into Indiana. That correlation, 0.03. So there are terrific benefits to blending together wind resources from distant regions in the country because they are non-correlating, and it makes wind overall a more valuable resource with lower integration costs. So I think I'm supposed to wait for questions, but yeah, so we'll wait just a second. I mentioned earlier a couple of our key partners, Southwire, that we're purchasing our all of the conductor for the project from Southwire. We also have partnered with Siemens for the HVDC technology. It all needs to be custom engineered for those converter stations, and there are only several suppliers in the world that are capable of doing that engineering, so we're very pleased to work with Siemens for the HVDC technology. And then Kiewit is a company that is one of the largest construction contractors in the country. They've built any number of projects across Illinois. They just finished rebuilding all the highway bridges in Missouri, and they have extensive experience with electric transmission as well. So we're utilizing them. One of the things we liked about them is they're very good at using local contractors. So we want to maximize the use of local construction in the project, and they're being very helpful in that. The other thing this slide shows is an anticipated timeline, and I mentioned that it's a 500-mile-long project, and I'm about to say more about some of the outreach that we have done. It takes a long time to do the routing and to do all the outreach that is required. We have now filed for our approval in Illinois, and we're getting ready to file next year or later this year in Iowa. Those regulatory processes take a couple of years. So when you go through a couple of years for the regulatory processes, and then you've got to finalize your land acquisition and finance the construction of the project, construction takes 2 to 3 years. You end up with a placed in service date of 2017 or 2018 is a pretty reasonable guess. So these projects, it's funny, we started this one in 2010. By electric transmission standards, that's actually moving at light speed. That's pretty fast. To normal people in their normal lives, it seems like an insanely long amount of time. All right, so I mentioned the extensive outreach that we're doing on the project. One of the most important things that we do is work to figure out what the route should be for the line. And so we started out with an area that was everywhere within the blue lines that you see there as our project area, and we met with all the county board chairs and conservation officials and people like that. And we narrowed it down based on the wind resource and based on what we learned to the light green areas on there. And we then invited 45,000 landowners, all of the landowners who lived within those green areas, to come to open houses. And we asked them for feedback on where we should route the line. And so we brought huge aerial maps where people could see, they could see their homes and their farms. They could also help us to identify, for instance, where local Girl Scout camps are, or popular boat launches, or cemeteries, pioneer cemeteries that may not be marked, or all of those kinds of things. So we're able to gather an enormous amount of data from all of those local stakeholders in a way that we just couldn't have done any other way. There's no way to get that sort of data from the Department of Natural Resources or anybody like that. So we spent a couple of years working on the routing there, and we narrowed it down to a final route, and that final route is what we filed in Illinois, and we're still finalizing the route here in Iowa, or there in Iowa today. What that does mean is we will be traversing agricultural land across Illinois and across Iowa extensively, and we are committed to being the best stewards that we possibly can be. We know that there will be a lot of issues that come up. We're going to have heavy construction equipment out in fields, and so we're going to need to proceed very carefully so that all of the fields are repaired to the condition that they were in prior to the beginning of construction of the project. We'll have an agreement with the Illinois Department of Agriculture that specifies lots of things, everything from picking up litter to how we'll resolve soil compaction and how we'll repair field tile and all of those sorts of issues. So there are a bunch of very significant issues that we'll have to deal with on the routing side. And I'll tell you that there are any number of landowners who are not thrilled with the idea of having a transmission line across their land. And so the fundamental question that we as a society need to sort of wrestle with is, do we want these new cleaner energy resources? And if we do want these new cleaner energy resources, then how do we want to go about doing the siting, and where should the line go. And we have made the best effort that we can make to reach out to people extensively and get feedback from them. But we are very conscious that not everybody is going to love and support the projects. So that, unfortunately, is the reality that we are in, and we as a society simply need to make a decision. Do we think it's important enough to get these clean resources built and online so that it is worthwhile to route a project like this across private farmland? So that then leads us to the sort of conclusion here, which is we are in these regulatory processes and we are working on the approval of the project. It would be very helpful to have support letters from people. I think Rob's going to pass some sample information and support letters around. There's lots of things you can do. You can friend us on Facebook. We're going to have public hearings later on. If you want to attend public hearings, we don't have the schedule for those yet, but if you sign up, we can get you on our list to do those things. One of the things you'll see is there's a public comment site on the ICC's webpage. It is not easy to use, but to understand how to do it, if you go to comment on a case, as is indicated there, if you go to www.icc.illinois.gov, comment on a case, and then you go and select P120560, as is indicated on this thing. It's not simple, but that will help you there. If you're here in person, Rob's passing that out, and we've got a printout that'll explain how you can go about doing that. If you get on that website and you look at the other comments, you will see that there are people who strongly support the project, and there are people who oppose the project, and that are very concerned about sort of the land use impacts. And so we take those concerns very seriously, but we believe that the consumer benefits and the environmental benefits of this project are so strong that the Commission should, in fact, approve the project. That is the presentation that I've got. I'd be happy to take questions either online or in person. I don't know if you still had a question back there.
Maybe, I don't know, but you can just probably have one on the end here. Could you give an example of, I mean, so through Hoover Dam is a good example. Is there a way to sort of put that example in the idea of if we built some coal power plant or some nuclear power plants in the backyard? Is that, I mean, that's another alternative is to build some power plants, right?
Oh, sure. So I'll repeat the question. You talked about Three Rivers. You mean like Three Gorges Dam? Is that the one you're trying to? Sorry, you mentioned the Hoover Dam. Oh, the Hoover Dam. Okay. All right. Yeah. So the question is effectively, yes, there are impacts from the transmission line development. However, there's also impacts from the other alternatives. So if you build coal plants, you've got associated impacts from mining, things like that, and the transportation and things of the coal. So you've got impacts all over the place. And I think that's exactly correct. There are impacts from any amount of any energy development. And so from that perspective, actually, when I was in state government previously, our perspective was always the first thing you should start with is energy efficiency, and you should make aggressive efforts on energy efficiency, and then after you've made those reasonable efforts, then you proceed with renewable energy. The state has adopted aggressive energy efficiency standards, and so they're actually seeking to not only stop load growth, but actually level that load growth out. But even with those aggressive standards, there still is, as I mentioned, the huge statutory requirements and other requirements for renewable energy. So, so we think that the demand is strong. But you're exactly right, if I got your question right, that there are very significant impacts from any type of energy development, and there's really no single silver bullet in energy development.
The East Coast governors can have signed petitions to Congress saying they do not want this energy. They would rather prefer using subsidy monies to build within their own state and grow their own economy. And I noticed your map didn't show offshore wind resources, which are Atlantic Ocean, the Great Lakes. How is your company addressing the issue that these are load areas that are in close proximity to offshore wind?
So our company, so the question is, what about offshore wind, and can we use more offshore wind?
How are you addressing it?
And then there was also a question about the governors in more easterly states. So offshore wind is a great resource, and I personally hope that a lot of offshore wind ultimately gets developed. In today's world, offshore wind is at least multiples of the price of onshore wind development, and that is something that I think policymakers can very fairly take into consideration. I will say, as a company, our company just was very pleased to announce a new investor, which is National Grid. And National Grid, so the reason National Grid got their name, National Grid, is they basically own all the transmission lines in England and Wales and the United Kingdom. They own the DC cables that connect England to Holland and England to France, and they're developing offshore wind in Scotland. They also own the electric distribution system in Massachusetts and elsewhere in New England, and they are the only company in the United States that has signed a long-term power purchase agreement for the Cape Wind project, which is the most famous offshore wind project in the United States. So that is the position of our investors, that they are actively supporting the development of offshore wind, and personally, I'm also a broad supporter of offshore wind. But it is more expensive than onshore wind, and I think it probably there will be some wind farms which will be hopefully developed in the very near future offshore, but the scale of the demand that we need, that we have for renewable energy, is such that I think it makes a lot of sense to develop projects like this today based on the cost effectiveness of those resources. You also mentioned a letter from governors, which, to be honest, I think you're mischaracterizing. There is a letter from 10 eastern governors that was sent in 2009, which was addressed to the leaders of Congress. And at that point, it was Speaker Pelosi and the rest of the leaders, because at that point the Democrats were in charge. It was the first 2 years of the Obama first term. And at that time, they sent a letter which was relevant to legislation and said that they did not want legislation that would subsidize projects, subsidize the transmission development for wind from the middle of the country. Our project is a merchant project, and we would not benefit from any federal subsidies at all. The letter very explicitly stated from the governors that they support wind energy anywhere in the country. And so they did not say they were opposed to wind energy development elsewhere. They simply said they didn't want it to be subsidized, and they did not support that legislation that would have subsidized it. So there's nothing about our project which is inconsistent with what those governors stated in their letter.
You just mentioned that you're a merchant line. Does it really matter if we pay ahead of time for it through our power bills, or if we pay afterwards for it? And the second part of that is, if you're a merchant line, why did Rock Island Clean Line just address FERC asking them to help subsidize them to do it?
So the question is about merchant transmission line projects and sort of what that means. And then there was another question about our recent filings with FERC. Just so people understand the vernacular here, there are two ways to sort of build a transmission line in the country. The most common model is what's called a cost-allocated transmission line model, which is you want to build a line from anywhere to anywhere. Then the regional transmission organization studies it and says, hey, this has reliability benefits or efficiency benefits or some kind of benefit, and therefore the costs are distributed across customers in that whole transmission region in some fashion. And so basically what that means is when you build a new power line, it shows up on your bill. It's in the transmission and distribution part of your bill. So if your bill down here is Illinois Power, then it's not in the energy portion, it's in the transmission and distribution sort of portion of your bill. So you don't have any options on that, it just appears. The other way is what we are actively developing this project is as a merchant project. And what that means is that the project would be financed by either the wind farms that are at the western end of the project or utilities that are at the eastern end of the project. So we get the regulatory approvals, and then we sign up customers who pay to move power on the line in a way that's very similar to toll roads. And so in that instance, then, the only people who pay for the line are the direct beneficiaries who have contracted with it. Now, that could end up meaning that there are direct people like you all who do end up paying for it if somewhere in the chain, if, for instance, your utility buys power from a wind company in Iowa and then they ship it over the line, then effectively our tariff is embedded in the net rate, the total final rate that you would pay. But it is not distributed broadly across a region regardless of who is consuming it. So it is a different model in that sense. Now, we have developed our project as a merchant model because basically the project starts in one region, which is called MISO, the Midwest Independent System Operator in Northwest Iowa, and delivers into PJM, which is the region I explained earlier that starts with ComEd and goes all the way to Pennsylvania and Jersey and Maryland. And there really are no rules in place to cost allocate a project that starts in one and delivers in the other. It's impossible. So under our current rules. We don't necessarily think that that's right. We kind of think that our project and other projects have a lot of value and that the regional transmission organizations ought to have rules to allow those kinds of projects to get financed in a normal way. However, because those rules don't exist today, we're developing the project under the rules as they do currently exist, and we're developing the project as a merchant project. So, if the rules change, we would be happy to look at developing the project as a cost-allocated project. In fact, if the rules change, we would have to, because if the rules change and you can cost allocate other projects which do the same thing, then nobody in their right mind would pay to be on our line if they can get on the other lines for free, right? So, so for that reason, we have told FERC that we think that there should be better mechanisms for cost allocation, but we've said, hey, in the meantime, we're just developing the project as a merchant project, which is the current rules. So I know that was all very complicated and long, but I hope it was at least reasonably clear. Yeah. Oh, good question. So there are two numbers that are on there. There's a $2 billion number, which is the total cost of just the transmission line project, if you will, our toll road portion of the project. The $7 billion number is the total value of the wind farms. So if you put the two together, you get $9 billion. The whole project overall, that's right. And just to pause on that, so the total project cost of the wind turbines and all of the equipment plus the transmission line, that being roughly $9 billion. To me, that sounds like a big number. If you look at the total amount of energy consumed in PJM, over the next 20 or 25 years, the total value of all of that electric energy, you're looking at a number that's probably $1 trillion or north of that. So in that perspective, $9 billion starts to look like a number that's not extremely out of the ordinary when you look at the total scale of the size of the market that we're delivering. Yes. Yes. So the question is how many wind turbines would be needed for the project, and the answer is going to depend on how many, on the size of the wind turbines. So you can go out and you can get a GE that's a 1.5 megawatt. Well, so we don't know the answer yet because we haven't signed our customer contracts yet. But just to answer the question, we don't know the size of the wind turbines that will be provided yet. They could be 1.5 megawatt turbines. They could be 2 megawatt turbines. They could be 3 megawatt turbines, right? But if you're looking at 2 megawatt turbines, if you just make that assumption, then it's about 2,000 turbines that would be built, in that 4-state region. And we would expect that most of that would be developed in Northwest Iowa. We were just talking about the number. I think we have north of 3,000 megawatts online in Illinois, but that's not the same as saying how many turbines we have in Illinois. So the number of turbines should be less than that. So the question is about are we filing to become a public utility in Illinois? And the answer is yes, we have filed to become a public utility in Illinois, just the same as many other private companies have filed to become public utilities in Illinois. So Illinois Power and ComEd and NICOR and Peoples Gas, those are all private companies that are public utilities.
So how do we get this moving before we advance this back? How do we find out what you do your financial?
All of our financial information, that is relevant is going to be considered in the Illinois Commerce Commission proceeding, and we do have an open docket, and people can intervene and participate in that docket. It's a public process, so those materials are available through that process.
There's no way we can find out if we want to invest in your company unless we go to the Illinois Commerce Commission.
Oh, I'm sorry. You're asking if you can invest in the company. You would like to invest in the company. So right now, as I mentioned, we just accepted an investment from National Grid, and we were very pleased to bring on that major new investment. We are not currently seeking any additional investors at this point.
So there's a private company, now owned by private, and where are they located?
So our majority owners, as I mentioned, are National Grid, which is our significant new investors, and then also based in New York, we have the Ziff family private equity fund, ZAM Ventures.
And what is the name of this private
ZAM,
family?
Z-A-M Ventures. It's the Ziff brothers. They're well-known active equity investors in New York.
Will anybody who's now in Illinois be able to use this power?
So the question is really the nature of our customers of the line, and we have applied to FERC and have been granted authority to negotiate the rates on the line. What we have said is that we will do a solicitation to find potential customers that will be public, and so we will identify those parties that are highly creditworthy and are reasonable to proceed further with, and then we can select up to 75% of the capacity on the line through anchor tenants, and then we will do an open season for the remaining portion, the remaining 25% of the line. But it will be a transparent process in terms of developing.
What population are you aiming for? Is it going to be Chicago?
So she's asked, the question is where would the power be delivered effectively? So the power would be delivered into PJM. So ComEd and ComEd's customers would be expected to benefit. Certainly the greatest portion of the consumer benefits that I mentioned earlier from the project would occur within the ComEd area. There would be some amount of those benefits that would sort of spill over the border into the MISO region, and the MISO region includes Ameren and Illinois Power, which is more local here. But most of the benefits would be in the northern part of the state. Yes.
Go ahead. You look smart at me. You're putting in your own transmission line, right? You got your own separate transmission line. So you can't rent space on where the regular transmission lines are, or there's a problem with HVDC on that.
So the question is whether we can utilize existing transmission structures and existing transmission rights-of-way to write the project. It's a very good question. I wish that we could. The problem is that existing transmission structures have all been engineered specifically for the conductors and the loadings that they already have. And so literally to try and put our conductors on existing structures. That they're not engineered to withstand that. And
They're not over-engineered to add any more.
Unfortunately, they're not.
They were years ago, right?
It would. So there are some issues regarding sort of interference back and forth between direct current and alternating current. And I do not have an engineering background myself, so I know that there are some level of issues associated with that. I would be happy to refer you to some of our to our engineering staff and get an answer. But I can tell you that it sort of, the answer sort of doesn't matter in that you can't share structures, existing structures anyway. So.
A technical question and a political question. Going back to that correlation matrix that you love so much, which I did too.
Okay.
If you look at that, if you could balance your load between Indiana and Kansas, it sounds like that would be perfect. If I'm reading this correct, that doesn't necessarily mean that between the two you have 100% capability of supplying demand.
What it simply means is that the Kansas wind resource and the Indiana wind resource have no predictive capacity over each other. So the fact that one is on doesn't mean that one is on, and the other is on, or the other is off. It simply means that they're completely independent. The point that we're trying to make is that if you blend a lot of resources together that are independent of each other, you're going to get something that starts to look pretty flat. So you will still see some seasonal variability, and you will see some time of day variability that will always be there with wind energy, but you're going to get a curve that's much more predictable, especially in short. This is for 10-minute periods. So you're going to really the sort of short gyrations in markets. A lot of that stuff will disappear.
Going back, following up on her question, I have heard there was the wind producers in New England were trying. Is that true? Is there, other than this thing that you mentioned is probably not really with the governors, is there a broader political opposition by East Coast wind producers towards bringing the Western wind into some of these?
So before, as Nancy mentioned, before I worked at Cleanline, I worked for the American Wind Energy Association, and I ran the state policy efforts across the country. And I can tell you that every state wants to maximize local economic development benefits, right? So you see it in the fact that, aside from California, New Jersey has incredibly robust solar power programs, right? And they have had a lot of success with that, and they've a lot of investment with that, and it's that they get to see the local, even though solar is a higher cost resource, they get to see the economic benefits of that, and they've been very supportive of that. And you're going to see that in one manner or another anywhere across the country. But I can also tell you that the other thing that legislators are always considering as they're adopting renewable standards is price. And so what you're really looking for is what's the right blend of price with local economic benefits that come with all of these new energy resources. And my experience tells me, as somebody who's worked across many of these states, that a project like ours, where if it's not 100% of where New Jersey is getting their power, but if it's getting blended in with some offshore, which is going to be more expensive, and some solar resources, that it's going to get, you're going to get a blended product that is going to be pretty attractive to consumers there in a variety of ways. So there are always those political concerns in every state.
An online here asks, what are the health effects to people who live on big lines?
So the question is, what are the health effects of living near the lines? There are no known health impacts from the EMF fields that are associated with these lines. There are EMF fields, but there are no known health impacts associated with them. The parallel question that often comes up as well is, what are the impacts to livestock? And there are similarly no known impacts to livestock. There have been extensive studies done specific to direct current, because I mentioned there's an existing direct current line in the Midwest that runs from Minnesota into North Dakota. And they've done extensive studies of the dairy herds that are in that area, keeping some of the herds directly underneath the conductors and others, several miles away, and feeding them the same exact food source. And they found absolutely no differences in productivity, reproductive health, in sort of milk fat content, or any of those kinds of things. They studied all of that, and they found absolutely no differences of any kind.
How many years did this go on?
The question is, how many years did those studies go on? They were long-term studies. I believe they went for the life of the cattle, but I would want to double check that fact. We do have that information available on our website, and I would be happy to provide those studies and others to people.
I believe that was in 1987 too.
I don't know the answer to that.
Yeah. Can you confirm that software should make the water?
So the question is, can we confirm that Southwire is going to make the wire and not just supply it? The full intent of the agreement is that Southwire will manufacture the conductor in their facility in Flora, Illinois. I've had the pleasure of touring that facility myself, and that's what they do. They make conductors. So yes.
One more quick on you're an expert on windmills, right?
In some regards, I'm not an engineer, so.
Okay.
Yeah.
I've heard that when blowing, I can see some windmills that are shut down. If there's too much power coming off the grid from those windmills, or it gets overcompensated, you have to those on automatic shutdown.
So the question is, when you have extreme wind, sometimes wind turbines shut down, and why is that the case? The answer is that can happen for a couple of different reasons. One, any turbine will have just a maximum shutoff speed, where if they get to going, if the wind is just too strong for the wind turbine to deal with, that can be very damaging to the motors and controls within the turbine, and so they'll just shut off, right? So that can happen in extreme high wind resources, or high wind periods. The other thing that can happen, which is more common, is that the grid can't handle the full productive capacity of the wind farm at that point. And so because the transmission grid is insufficient, they just have to turn the wind farm off. And that's called curtailment. And curtailment has been becoming more common. It's much more common in Iowa and in the MISO area. But one of the benefits of a project like ours is delivering right into the 765 kV system, which is the backbone industrial grid in the country, really minimizes those sorts of impacts and just allows the new wind farms to be built. Yeah. Effectively, the purpose of the project is to allow new wind farms to get built and to have them be built in a way that you're not going to have the level of curtailment that you do. That's right.
But similarly, natural gas peaker plants are curtailed 90% of the year. It's for economic reasons, but
yeah. I mean, there are many natural gas. So the question was about natural gas turbines. And there are many natural gas peaker systems that they can operate profitably, operating 5% of the year. All right.
On such a long distance, having power, you go to DC, how much whether the mechanics may have to deal with the rules in that health issue? Because you're going to lose power, you're going to have to lose power going that long distance.
So the question is about EMF and load losses. The load losses, as I mentioned earlier, we anticipate will be approximately 5% full in over the full 500 miles. EMF, if there is energy on the line, there will be some EMF on the line. That the two go together, so that doesn't really dissipate.
Is there any studies on talked about on the cattle versus
So there have been a large number of studies on AC systems and things like that over the years, and we do have a brochure that summarizes the various World Health Organizations, the guidance that they provide on EMF and EMF exposures, and so happy to make that information available. And as I mentioned, some of that information is on our website. So I think I gave her out on my Final slide there. My email address there is at the bottom. So if anybody can't find any of this information on the website and wants the information, you can request it from my email address there.
One last question. How is this project coordinated or planned with the other 8 or 10 high voltage transmission lines going through Illinois projected?
So the question is, how is the project planned, and what about the other project and coordinated?
Are you working together, or is everybody doing their own hogs of the trough to try to get across Illinois to the grid?
The question is, how are we coordinated and how are we planned with the other projects that are in the system? So as I mentioned earlier, our project is being proposed as a merchant project. So we are in what is called the PJM's Merchant Transmission Interconnection Queue. And so we are participating in PJM's studying and coordinating processes as a result of being in that interconnection queue.
Aren't most of these others coming from public utilities that already have existing public utility standards? So are you coordinating with them, with the Amarin Rivers project? So
the question is, what about the other transmission lines and what do they do that are not merchant projects? So the projects that are not merchant projects are going through the planning processes for the 2 RTOs. If it's Amarin, then they're within the MISO planning process, and MISO has a process called MVP, which stands for multi-value projects, and so MISO studies the benefits and costs of all of those projects as well. So the answer to your question, regardless of whether you're an AC project or a DC project or a merchant project or a cost-allocated project, is that those regional transmission organizations, MISO and PJM, are the ones who are coordinating